Welcome back, focus learners, to another explainer. Today, we're diving into something incredibly thought-provoking. We are looking at a recent, highly structured argument put forward by a physics professor who pointed out a massive friction point. Basically, when you apply the actual established laws of quantum physics to the official NASA narrative regarding the moon landing, something fundamentally breaks. So we're going to examine this friction completely impartially through the dual lenses of physics and sociology. And right up front, let's be crystal clear about what we are doing in this explainer. We are looking objectively at genuine questions being asked by actual physicists. We are not diving into wild conspiracy theories today. We're looking at specific mathematical and physical anomalies that NASA really hasn't fully answered yet. It is a genuine scientific mystery that absolutely deserves our critical attention. Okay, Section 1. Artemis sparks new debates. So just weeks ago, NASA completed the Artemis II mission, returning humans to lunar orbit for the first time since Apollo. Now, you'd think this triumph would silence the skeptics, right? But it actually caused an absolute explosion of public skepticism. We had public figures asking questions and millions of people out there dissecting NASA's own footage. Sure, there was plenty of noisy internet speculation, including that viral image of the Orientala Basin that reached tens of millions before being totally debunked as an AI fake. But beneath all that noise, physicists noticed something much more grounded. Okay, let's dive into this step by step. When you put the recent 2026 Artemis footage right next to the 1969 Apollo footage, the visuals just simply don't match up. Step 1. The lighting behaves completely differently in the vacuum of space. Step 2, the shadows are falling at completely different angles. And step 3, the way the Earth appears in the background, its angular size, literally defies what basic orbital mechanics would predict between the two missions. This debate perfectly captures two conflicting perspectives. On the left side, we have NASA's entirely valid argument: we're using modern camera technology, completely different digital sensors, and advanced image processing today. That's a totally fair scientific point. But from the physicist's perspective on the right, these visual discrepancies are just too fundamental to brush aside. It's not just about crisp resolution. It's about the underlying physics of how light and scale actually operate in those images. It really demands a deeper, objective look. Moving right along to Section 2, the radiation shielding puzzle. Let's transition over to the hard science of the mission. Back in 1969, to get to the moon, the Apollo 11 crew had to travel right through the Van Allen radiation belts. These are two incredibly intense bands of radiation surrounding the Earth, held securely in place by our planet's magnetic fields. While the outer radiation belt peaks way out at around 25,000 kilometers, the super intense inner radiation belt sits right between 1,000 to 6,000 kilometers above the Earth. And to reach the moon, you literally must pass through both. This is a zone strictly governed by quantum mechanics at the subatomic level, radiation intense enough to cause cumulative DNA damage and physically degrade silicon chips. And crucially, that intense radiation degrades photographic film. The Apollo 11 astronauts were carrying cameras loaded with Kodak Ektachrome film. Basically, that's your standard silver halide emulsion film. Well, based on the radiation flux calculations published by NASA itself, unshielded silver halide emulsion passing through those inner belts should have suffered near total degradation, or at the very least, severe exposure fogging. Now, this table brilliantly illustrates the friction we're talking about. Based on quantum physics, we'd expect severe radiation fogging and completely ruined exposures. Yet the actual Apollo 11 results yielded crystal clear images, zero fogging, and absolutely perfect exposure. NASA claims the cameras were shielded to prevent this. The problem? Those specific shielding specs were never fully declassified. Furthermore, no independent laboratory has ever been able to replicate that level of radiation shielding at that highly specific 1960s weight-to-protection ratio. It's a literal missing piece of the physics puzzle. Which brings us to Section 3, shadows, flags, and stars. Let's shift our focus to three very specific, persistent physical anomalies from the lunar surface footage itself that have really fueled modern debates. First up, the famous American flag. NASA says the flag appears to wave because it's simply vibrating from the force of being planted into the ground. Yes, intuitively, that makes a lot of sense, but we have to look at the physics here. Frame-by-frame analysis highlights a major observed anomaly. The flag moves in a pattern that is entirely inconsistent with a dying vibration in a vacuum. Remember, there's no atmosphere on the moon. Waving typically requires a medium, like wind or air, to actually propagate through. Next, we have the shadows. NASA rightly points out that the moon is a single-source light environment, illuminated entirely by the sun. The physics of a single light source dictate that shadows should fall strictly parallel to one another. However, the observed anomaly in multiple photographs shows shadows falling in entirely different directions, often at intersecting angles. As any photographer or physicist will tell you, achieving that visual effect usually requires multiple light sources, closely resembling a studio lighting setup. Finally, the stars. With zero atmosphere and zero light pollution, the lunar night sky should be visually spectacular, right? Yet there is not a single star visible in any Apollo lunar surface photograph. Now, NASA's explanation here is actually perfectly sound for the bright side. The camera exposure settings were specifically calibrated for the incredibly bright lunar surface, which naturally washes out faint starlight. But here is the glaring mystery. There are photographs taken during the dark side pass of the moon. And in those dark side photographs, still zero stars. Just completely black. So what does this all mean? The crucial point we are neutrally observing here is this. Accepting the official narrative often means accepting that each answer requires a highly specific, very convenient failure of observable quantum and physical laws, happening in exactly the right way at exactly the right moment. Let's slow things down a bit for Section 4, the real trust crisis. Let's pivot from scientific forensics to the massive sociological impact of these modern debates. I want you to consider this question for just a second. We just sent humans back to lunar orbit. We have live, high-definition footage streaming back. We have terabytes of new data. Why didn't the skepticism just vanish? Why did the conspiracy theory actually get significantly bigger in 2026? Well, the answer lies in public trust, which is currently sitting at a historic low. Audiences today have lived through a heavily documented history of institutional lies. Think about it. When people have been misled about massive, world-altering things like weapons of mass destruction, covert domestic surveillance programs, or the safety of major pharmaceuticals, when lie after documented lie is confirmed by history, it actually becomes rationally defensible for the everyday public to suddenly question things that were previously considered absolutely unquestionable. Which brings us to this profound takeaway from our source material today. The modern moon landing debate isn't actually just about the moon landing anymore. It is a societal symptom. It essentially represents the accumulated weight of institutional dishonesty. And in a really fascinating way, that is a physics problem that nobody at NASA has any idea how to solve, because they can build rockets, for sure, but they cannot engineer public trust once it has degraded. I want to leave you with this provocative challenge today. If you have a background in physics, we want you to independently break down the math, explain the Van Allen radiation shielding problem, run those film exposure equations yourself. Because if the scientific answer is out there, let's find it together. And if it isn't, well, then we have a very, very different conversation to have as a society. Thank you so much for joining me for this explainer. Make sure you stay focused and curious, because next week we are going to dive into a complete frame-by-frame analysis of the Artemis II anomalies. You definitely won't want to miss it.